All right, so I'm going to go over how to do valence electrons and ions. So you need to answer the questions from slide 2. Slide 3, we're looking at a magnesium atom. So you have to look at your periodic table to figure out its atomic number. Its atomic number is going to be 12. Your protons are equal to your atomic number, so it's also 12. And since we're looking at an atom, your electrons are also going to be 12 because they're all going to be equal to one another. So since your protons are equal to your electrons, your overall charge is going to be 0. Now, you have to do a Bohr diagram for it. So you have to follow the set number that you can put in each level. So the first level can hold 2 electrons. So we're going to put 2 electrons. Our next level can hold 8. So we're going to put 8 electrons in our next level. Right, so now we have 10 out of our 12, so therefore we're going to go to our last shell. So therefore we need to have 2 more. So we're going to put 2 red dots to show our valence electrons. So now we've created a Bohr model for a magnesium atom. We're going to take what we just did and do a magnesium ion. So we're going to recreate the Bohr model that we just did with our 2 blue electrons for our first level, our 8 electrons for the second level, and we're going to put our 2 valence electrons. But in directions it says to take away 2 electrons from the outer shell, so there would be no more electrons in the outer shell. Okay, so we want to take those 2 electrons and put them back at the top. So now we have no valence electrons. So now we can answer the questions because we followed directions. Atomic number remains the same as 12. Protons remains the same as 12. But now for electrons, we count how many blue dots we have. We only have 10. So now we have to figure out overall charge. We have a positive 12 and we have a negative 10. If we were to take away, if we look, we have more positives than negatives, so we're going to have plus. And then we have 12 minus 10, so we have 2, so we're going to have a positive 2 as our overall charge. Now we're going to look at fluorine. Its atomic number is 9. We're looking at an atom, so our protons is 9, and our electrons are also 9. So our overall charge should be 0 because we're looking at the charge of an atom. So our overall charge should be neutral. We're going to place our dots where they need to go. So we're going to put 2 in the first shell. We're going to use red because there's only 2 shells that are going to be occupied here. So we're going to put 7 in our second shell. And now we've created our Bohr model for a fluorine atom. Now we want to take and turn that fluorine atom into an ion. So we're going to recreate what we just did for a Bohr model. So put our 2 blue in the first shell, put our 7 in the second shell, but now in the directions it says add 1 more electron in the outer shell, so there are a total of 8 electrons in the outer shell. So we're going to carry 1 more electron down, place it somewhere in that second shell. So now we have a total of 8 electrons in our outer shell there. So now our atomic number hasn't changed, even though it's an ion, so it's still 9. Our protons have not changed, so it's also 9. But our electrons have now changed. Now we have 10. All right, so we have more negatives than, So our charge is going to be negative, and the difference between 9 and 10 is 1, so our charge is negative 1. Now you're going to complete the rest of the worksheet using your notes for Chapter 5 and Chapter 6 here, and do your Bohr models for your atoms and your ions.